In this lecture, we are going to go over the concept of standard deviation and variance. So the standard deviation and the variance represents the variability around the measure of center, such as mean. So we want to study what is the variability around the mean, and that's why we make use of the standard deviation and variance. So let me give you an example to signify how this can be used, what is the importance of this concept. So let's look at the two different settings and let's see if you have two different data. You have created histograms for two of this data from your, let's say, lab 1, and this is regarding, let's say, temperature. So temperature in lab 1 setting, and then you have the average temperature, let's say 60 degree Fahrenheit. So this is your data 1 and the histogram first for this data. Let's say now you have another data from lab 2 and you want to see which lab is better for your experimentation purpose. So most commonly it can be done for microbiology experimentations. So you need to know the temperature in the lab, right? So this is for lab 2, and let's look at the let's plot the histogram for the temperature in the lab 2, and these are like the repetitive measurements of the temperature in the lab. So maybe you can consider these as temperature values over a period of several days or even hours, right? And let's say that if we calculate the mean, so this was first mean for first lab 60 degree. Let's say that even for the second lab you have the same or similar mean. So for simplicity and explanation purpose, let's say that the mean x2 is also 60 degree Fahrenheit. So now looking at these two different histograms based on this data from two different labs, which one you should go for? Should you use lab 1 for your experimentation? Should you use lab 2? So that is the question, right? So that question can be answered by looking at the variability. So if you look at the lab 1, you can see that the both the lab have same mean temperature, but there is like very less variability around this mean. So when I say the variability, that means the deviation from the mean. So maybe you can get some fluctuation around that mean, but it's not a lot compared to this. Some days or some hours you have this much, sometimes this much, sometimes even further uh, deviation, right? So maybe sometime you might get something like 0 degree Fahrenheit, let's say, as an example, and someday you might get something like at 90 degree Fahrenheit. So that's like not, that's like uh, very unpredictable, or like having more deviation in this data. So that is why we need to understand what is the deviation in your data set, and for that we need to go ahead and compute the standard deviation or the variance. Now both the things are based on the same concept of variability. Now why do we study the variance and standard deviation separately? So the reason for that is simply the unit involved, and that is for the convenience purposes, so for interpretation and correlation. So we are going to look into that once we go over this example. So let me go over this example and we should be able to answer that questions completely by the end. So let's look at this another data. Let's say these are some measurements given to you for 7 different individuals. So 1 2 3, 4, 5, 6, 7. Oh, 2, 3, 4, 5, 6, 7. Okay, so 7 different data points you have. Then let's plot a dot plot here. That's like the extension, or like the first step for histogram. So now instead of histogram we are going to create dot plot, because it's like smaller data set. It's like the same, based on the same principle, but we just represent it in the form of dots. So let's say an average mean here is 1600, that's given to you, and maybe I'm going to scale it as 17, 18, 1900, 15, 1400, and 13. So let's plot this data points. Alright, so let me make sure that both the data points and the graph can be visualized at the same time. Alright, so now let's plot the first data point, 1792. That should be somewhere around here, right? Then 1600 should be 16666, should be somewhere around this. Then 1362, now it's going to be on the other side, right? So 13, so this is 1300, so 1362 should be somewhere around here. 1614 should be somewhere around here. 1460 here, and 1867, and the last one is 1439. So now this is how our dot plot looks like. So in histogram usually you're going to have like larger data, so you are going to have like lot of uh, dots that are representing each of the data points, and if you have the same dots you are going to just stack them up, and that's how you get like the higher height of that particular bar of histogram, right? But for simplicity let's just stick to this, and we know that this is the mean x bar 1600. So in standard deviation we want to analyze the spread of data. So how is the data spreaded around the mean? So grossly you can just consider one particular distance, and then maybe you can consider this is the standard, not standard but some reference distance that you can use to describe the data point. But this is again like the subjective, right? And we want something which is standardized. So that's why we go for the calculation for standard deviation, to get the standard form of deviation that we can discuss. So first thing you need to know in here is what are these distances that we are going to look for. So these are nothing but the distances of each of these data points. So let's say our first data point is 1792. You can see here 1792, which is somewhere around here. So distance of that data point from the mean. So that distance is one of the distance, and similarly we are going to calculate each of these distances to get one standard distance that we can refer to, right? So it can also be uh, considered as sort of average of deviations, these deviations, but it's not exactly like that, and we're going to see that. So now this much variability can be expected. Like if you go for all the individual data point, you can see that the deviations, how is the deviation. And if you consider the variability, you usually look for the area. So if you consider this as square, you will be considering the area of this square, and the area of this square, you know, the area for square is the side square. and you're going to get the area for this entire square highlighted here. So that is going to give you variance. And if you go on and create similar squares for each of the data points, like for this data point it's going to be somewhere here, for this data point it's going to be something like this, for this data point it's going to be something like this, on so on. So that is how you're going to get the areas covered by these data points, which is going to give you the variance, right? But the problem with the variance is that the variance unit is in the squared terms. Like if this data is regarding some centimeter measurements, then it's going to be the centimeter square. But your all these data points, each of them are in, let's say, unit of centimeter. How are you really going to correlate that variance, which is in centimeter square, to the each of these data points or any of these data points which are in centimeter or non-squared unit? So that is why we go for standard deviation, which is square root of that variance, right? V here represents variance. So now, why do we need to take the square root? Not just because of the unit, but as we saw that, let's say again, let me draw that this is a square representing the variability from the mean. So instead of taking this entire square, why not just take the side, one side, right? So if we are going to take the one side, let's say this one, so that means we are measuring a distance, because this side of that square also represents the distance of this point from the mean. This is our x1, 1792, right? And likewise, instead of squares, you are going to calculate the distances. So this is going to be a second distance difference from the mean, right? So those are nothing but deviations which we calculate in the standard deviation process. So you're going to calculate such distances by subtracting the mean or the higher number from the lower number of the data point, right? Similarly, you can do it from the others for the other side. And remember that on the other side, you are going to get all these distances as negative. So if you add them, take the sum of these data points or the distances from the data points, the sum is going to be 0, right? So that's one method to understand and cross-check the standard deviation calculation, because we know that we use these standard deviation to find the variability around the mean, and mean we know it should be center unless the data is skewed or having high outlier, right? All right, so now we know why do we need to calculate this standard deviation, right? So this is how we are going to, and there is like calculations we do further using this formula, and that is how we are going to get some measure which we can call it as a standard deviation, right? And in terms of that standard deviation, we can represent how the distribution looks like. So is it one standard deviation this much? So is this the two standard deviation, and so on, right? So now let me explain you the concept in this formula, which is for standard deviation, where n represents total number of data points or individual data points. In here these are 7, so n is 7 here, but we use n minus 1, which is nothing but degrees of freedom. So I'm not going to go in detail for this degree of freedom. You might want to check the textbook for more details. This practice for health statistics, but it's overall it's like when you use one piece of information, you have independence for variability of n minus 1 terms, so that's why we use that. And also it's been demonstrated by statisticians. If you divide it by degree of freedom, you are going to get more more appropriate standard deviation. rather than just dividing it by n. So now you know what is n minus 1. You can solve this part. So what is this part? This is nothing but the distance that we looked for, right? These distances which are in the black arrows, and you then square them up and then take the summation. So basically some kind of average sort of deviation. Now this is not average because you are not dividing it by an degree of freedom, so that is the reason. And once you solve this by taking summation, you should be able to get the answer for standard deviation. So, and we are going to describe the step-by-step process in the next video, but let me highlight some of the important properties of the standard deviations. So one of the property of standard deviation is that it just represents the spread of data, right? How the spread looks like. But the limitation is that it can only be used when mean is appropriate measure of center. What do we mean by that? We know that the mean is resistant to skewness or outlier, right? So it won't change. So when you have everything appropriate, mean is an appropriate measure, you can go ahead and use the standard deviation. But let's say if you have outlier or skewness next to your data, then instead of standard deviation, you should go for 5-number summary to summarize your data. Why? Because in this case we use median, right? Median is resistant to skewness while the mean is not. So if your data is skewed on the right side, your mean is going to get pulled to the right side, right? So that is one consideration you have to think about. The another property of standard deviation is it can be either 0 or positive number, right? Because we are taking those squared, so squares of those distances. And when you have the standard deviation as 0, that simply means your data is not having any variability, so it is not varying, right? The third property is the reason behind using standard deviation versus the variance, that it has got the same unit as each or all the data points, right? And that is why you can directly correlate your data point with the standard deviation. How far is one data point from the mean? How much it is varying?